Right. Good evening. Welcome to day 10 of Electrical Safety Specialist course. Today we will start module number 4, the risk assessment, and this basically complies with the article 130. So here in this risk assessment, it takes into the consideration when you are performing some justified and live work uh, as per the exemption category given in article 110.4 A, B, C, or D. Then you have to perform a risk assessment before starting any live task. Also, if you have been given a task to establish an electrically safe work condition, so the act of establishing an electrically safe work condition is considered as a justified and an authorized work. A risk assessment is also required. Once an electrically safe work condition is created, then further you are not required to wear any electrical personal protective equipment or arc flash PPs. But after establishing an electrically safe work condition at that particular location, you are performing some electrical task like diagnostic, or you are using some electrical hand tools or other thing. Then a separate risk assessment will be performed uh, to uh, to look into this thing, that how the task will be performed in that particular case, and what are the PPs are required. But the initial personal protective equipment which was required for establishing an electrically safe work condition will not be required further. For example, initial risk assessment informed that there was an incident energy of 24 cals per centimeter square, and the voltage level was, for example, you was working on 11 kV voltage level, so you wear the personal protective equipment of rated for that particular voltage level, and also for that particular incident energy of 24 cals per centimeter square. Once you have established an electrically safe work condition at location B, where you will be performing some task, electrical tasks. So at location B, you don't need to wear that 24 cals per centimeter square of arc flash suit and the gloves of 11 kV. At that particular location, you might be using some hand tools, or you might be performing some electrical testing at voltage 400 volts. So then the requirement of wearing the personal protective equipment of 400 volt is required. And if there is a chances, or if there is an incident energy available, or the R flash hazard exists, then you will be wearing a personal protective equipment or R rated equipment related to that particular voltage level. Does this make sense? It's okay. Any question on this one?
No questions.
Okay, moving forward. So here now we are on this one, article 130, and it discussed that how you will going to proceed to perform the work on the live system. So once we have completed this module, we know that what are the tasks which require energized electric work permit, the elements of energized electric work permit, the exemptions to energized electric work permit, completion of energized electric work permit, and to perform shock and arc flash risk assessment. So starting with one case study, Anne was an electrician for an electrical contracting firm. He arrived at a work site to conduct tasks assigned by the host employer. A documented meeting was held between the two. So one of the requirement of documented meeting between the host employer and contracted employer was carried out. The host employer provided information on the electrical hazard within the equipment and documentation regarding the risk assessment for the equipment and the task. The initial task was to be voltage measurement in a 600 volt motor control center. So the initial task was only voltage measurement. The risk assessment provided by the host employer equipment label indicate that the incident energy of 5.1 cals per centimeter square was there at a working distance of 18 inches. He basically wear an 8 cals per centimeter square of PP that was provided by his employer. During the act of measuring the terminal voltage, an arc flash occurred. It was not determined what had initiated the incident, and was non-responsive when the plant supervisor found him with his PP severely damaged. He was rushed to hospital and sustained third-degree burn, nearly 60% of the body. The injury was so severe that he died 3 weeks later. So in this particular case scenario, we can see that everything was going right. The documented meeting was there. The task of voltage measurement basically falls under the infeasibility of Article 110.4b. So this task need to be performed on the live part. Energized selective work permit is not mandatory requirement when we are performing this this voltage measuring or inspection task that we will going to see shortly. That falls under the exemptions category of energized selective work permit. But if but if the employer wants that they will be carrying out this thing, so it's up to them. Then the risk assessment showed that the incident energy was around 5.1 cals per centimeter square, but 5.1 cals per centimeter square, and he was wearing an arc flash suit of rating 8 cals per centimeter square just to give him an extra cushion. But still, the PP did not work out during that incident. So either there was an issue with the calculation of the incident energy. The incident energy was calculated to be 5.1. Maybe the actual incident energy release was more than 5.1 cals per centimeter square, or there was an issue with the personal protective equipment itself. So they carried out the root cause analysis and they tried to find what actually went wrong. The risk assessment and information on the equipment level were appropriate for the task. Inspection of the label on his arc rated indicated an 8 cals per centimeter square, principally based on a specific testing standard, but it was not based on the testing method which was specified by the NFPA. The work procedure was deemed to be sufficient. So there was no issue with the work procedure. There was no issue with the risk assessment and the information. So what was the root cause? From the label information, it was determined that the arc rating of PP had not been properly evaluated, and the PP was not capable of withstanding the incident energy exposure. Relevant NFPA 70E requirement: the PP used must provide protection to the employee. The PP must conform to the applicable standard. These are the requirements of NFPA 70E, and these basically fall under the employer responsibility that they should provide those personal protective equipment to their employee who is which are tested at a certain level. Okay, so they are tested against a certain standard which fulfill the requirements of NFPA 70E. 130.1 talks about work involving electrical hazards. So Article 130 covers requirements for work involving electrical hazards, such as electrical safety related work practices, assessments. Yes, Tanzil, please.
Sir, there is any PP which clearly categorically has any stamp, any NFPA 70 conformity or something?
Basically, it won't be saying that NFPA 70E conformity. It will represent the ASTM standard, or that I will going to cover in module number 5. But you have asked the question. Let me take you to the one table. There is a table given here. Information note standards for PP. So for clothing arc rating, the PP must conform to ASTM F1506. Okay, or other type of the standard is ASTM F1449. So there are different type of the related to maintenance, thermal, and arc rating. Similarly, for other type of the PPs related to face shield, eye and aprons, footwear, etc. So the ASTM standards are there, right?
Okay, sir.
So Article 130 covers requirements for work involving electrical hazards such as electrical safety related work practices, assessment, precautions, and procedure when an electrically safe work condition cannot be established. So this covers when you will be performing some live work and when the electrically safe work condition cannot be established. The safety related work practices shall be used to safeguard employees from injury while they are exposed to electrical hazards from electrical conductors and circuit parts that are or can become energized. 130.1 talks about general requirement when energized electric conductor and circuit parts operating at voltage equal to or greater than 50 volts are not put into an electrically safe work condition. The work is performed as permitted in accordance with article 110.4. All of the following requirements shall apply. Only qualified person shall be permitted to work on electrical conductor or circuit part that have not been put into an electrically safe work condition. An energized electric work permit shall be completed as required by 130.2. A shock risk assessment need to be performed and arc flash risk assessment need to be performed. All requirements of Article 130 shall apply whether an incident energy analysis method is used or if you are using a PP category method. So 30.1 says that when the work is permitted in accordance with Article 110.4, then only you can perform some live work. And those live work need to be performed by only qualified person. Okay. And an energized electric work permit need to be filled, shock risk assessment need to be completed, and arc flash risk assessment need to be completed as well. Let's see energized electric work permit, how it's looked like and why it is important. So it is covered in 130.2. So this basically, when it is required, when work is performed inside the restricted approach boundary. So if you are performing any job within the restricted approach boundary, an energized electric work permit is required. When employee interacts with equipment without exposed conductor or circuit part, but there is a likelihood of arc flash, then again an energized electric work permit is also required. What is the intent of permit? It requires management to sign and agree, and it also serve as a checklist that you have carried out the required risk assessment, and you accept that this task can be performed on the live, and it need to be signed by the management that they agree that this work can be performed on the live. If you look into the elements of energized electric work permit, EEWP, you will going to find there are three different sections or part. First part need to be completed by the requester. It's like a production manager, maintenance manager who is requesting the energized electric work that they have got some fault, and they are requesting for any type of the work, and they are trying to put the justification that why energized electric work permit is required. So if the justification which they are giving is in terms of in order to avoid production losses or downtime, then that type of the explanation or the reason will not be accepted. But if they are giving a justification for that, if we're going to create and establish, or if we establish an electrically safe work condition, it will going to create additional hazard or increased risk. So under that category, a justification can be accepted. The part 2, which need to be completed by electrically qualified person who is actually doing that particular task. So he will be performing all the task, and he will be giving his consonant that this task can perform on the live or not. In part 7, you can see that, do you agree the above described work can be done safely? So if no, then this will be requested back to the back to the requester. But if it is yes here, then he agrees that this task can be performed, and then he will be moving to part number 3 for the approval stage. So part 3, approval to perform the work while electrically energized. The manufacturing manager, safety manager, and general manager are or any one of them will be signing this energized selective work permit, that they agree and they are aware of that this task has been accepted to be performed on the live system. So what is general rule? Energized selective work permit general rule: who is requesting the work, who is performing the work, and who is basically authorizing the work. So there are three things: who is requesting the actual work, who will going to perform that particular work, and who is authorizing that work. So part number one is about who is requesting the work: maintenance manager, production manager, or any other department, facility manager. Who is performing the work? The qualified person himself. Who is authorizing the work? Someone who is at the next level or the higher level in the hierarchy than the qualified person themselves. So by authorizing by shifting the authorization responsibility to other person than the qualified person, is due to the fact that a qualified person should not authorize their own work. Qualified person are there to perform the risk assessment and to give their opinion whether this task can be performed on the live or not. Then someone in the main responsibility will be basically authorizing that work, and now they are taking the responsibility as well. So if anything goes wrong, so the people who are sitting in the upper management or the top management are also responsible. So what is one advantage of shifting this approval to the top management? Yes, it will take more time for authorization, but now the top management will understand that they are equally responsible, and they are sharing the responsibility of that live work. So you will going to find drastic decrease in the live work in your own organization. The number of the live work will going to decrease, because the management is authorizing those work. So management must sign and agree that energized work is justified. So once energized selective work is properly justified, the hierarchy of risk control has been applied. So if we are completing an energized selective work permit, and the management is justifying or have approved, that means we have applied the hierarchy of risk control. We have look into the option that this task can that the elimination is not the option, substitution is not the option, engineering control is not the option. Then we are going with the awareness, administrative control, and the personal protective equipment to complete that particular task. So the basic purpose of energized selective work permit is to ensure that people in the responsible positions are involved in the decision whether or not to accept the increased risk associated with working on energized electric conductors or circuit parts. The additional benefit of the EEWP is that its review might initiate our decision to perform the work de-energized. So this might going to provide them information that it's better to perform work on de-energized rather than performing the task on the energized state. Okay, let's review one of the case study. Joe has been asked to determine the cause of failure of 3 CNC machines that have become non-operational at KTV tool and die. The machine failed in the middle of the large production run that is scheduled to be completed by the end of the day. Joe determines that the failure has taken place in the motor control center that feeds the machine on the production floor. During his effort to troubleshoot the issue, he has found a connection within the motor control has come loose and has disconnected the cubicle that controls all 3 machines. Joe must now go into the MCC to repair the connection. The plant manager is adamant that Joe do this and this energize, so that he does not need to de-energize the other CNC machine that are still operational, as this would cause him to miss his deadline and cause the company a large amount of money. Joe understands that the work has switched from diagnostic to repair. The MCC is supplied by 1200 amp fuse switch in the main switchgear of the building. The voltage supplying this MCC is 400 volts, 3-phase. Okay, so this is basically the scenario. So based on that scenario, the plant manager is asking to perform that particular task on the live system, and he is requesting this. Okay, and what justification he will going to put in here? Just see that thing. The description he has given, the condition of the equipment he has given, and justification, it says that it is infeasible to shut down the remaining production line because of a tight deadline. So this type of the justification is not acceptable as per 70E for energized electric work, because the justification should fulfill the requirement or should be in compliance with the article 110.4 exemptions category. So it does not fulfill. That's why the qualified person should not sign this energized electric work permit, or should not agree that I will be completing this work on the live and then forwarding that energized electric work permit to the top management for their approval and signature. Okay. Now I have in that student manual, I have shared with you people an energized electric work permit template here. Okay, so this is with the email which I shared with you people. So it's an editable one. You can write your job order number, description of work to be performed, justification, part to be complete by the qualified person. So this you can directly start with the implementation. So if we look into the energized electric work permit, so first part we have seen the description of the circuit, description of the work to be done, justification of why the circuit cannot be de-energized or work deferred to the until the next outage cycle. So it is filled. Then what the qualified person will do, he will going to also write the description procedure in the technical term or which is suitable to him. The description of the work practices he will going to apply in order to perform that particular task. The result of the shock risk assessment, he will going to write the result of the shock risk assessment, yani what's the voltage level to which he will be exposed to, the limited approach boundary, restricted approach boundary, and the personal protective equipment he will be wearing. Then the arc flash risk assessment, what's the incident energy available there, and the personal protective equipment he will be using, and the arc flash boundary. Then in part number 5, what means he will going to apply to restrict the unqualified person who want to enter in those area. How we're going to ensure that those person are not being able to enter those area. Then the evidence for the completion of job briefing and job planning, his agreement that this task can be performed safely. And the final thing is with the approval, manufacturing person approvals, safety manager approvals, and other approvals here. So this is the template, or this is the energized electric work permit I have shared with you people. So just try to complete some energized electric work permit for your facility to determine whether the tasks which are being performed on the live are justified or not. Any questions up till now? All good. So 130.26 talks about the exemptions for energized electric work permit. So there are certain conditions. We know that there are multiple type of the tasks are being performed around electrical equipment and electrical system. It should be like this, that all the electrical tasks should make it mandatory that energized electric work permit is required. But NFPA 70 provides exemption that there are certain tasks in which it's an optional, that if you want to complete an energized electric work permit is up to you, but 70E does not make it mandatory. For example, if the qualified person, a permit is not required if a qualified person using safe work practices and PP in accordance with chapter number 1. So a qualified person who is wearing the required personal protective equipment, who is following the safe work practices, he's performing some testing, troubleshooting, voltage measuring. The permit is not required. There is an exemptions to the permit is there. He's performing some thermography, visual inspection outside the restricted approach boundary. The permit, energized selective work permit, is not mandatory requirement. He's performing some housekeeping outside the restricted approach boundary, and access and egress outside the restricted approach boundary. So these, if he's performing these tasks, then energized selective work permit is not required, is not mandatory. But having said this, these tasks which he's performing does not indicate that the risk is not there. The risk is there. The shock, the shock hazard exists. The arc flash hazard exists. The risk might be there. Okay, so but what is not there? It's like that. There is an exemption. There is an exemption to the work permit is there. Okay, so exemptions to the work permit does not indicate that the hazard is not present or the risk level is low. That's why 70E says that employers may wish to consider a permit anyway in order to identify what the risk level is there. Okay, so don't confuse this with the concept that in exam, if they try to test your knowledge or concept that the energized selective work permit is exempted because the hazard is not there. The or the risks associated with that hazard is so much low. That's why energized selective work permit is exempted. No, this is not the case. 70E has given exemption for these tasks, but these tasks itself are very risky, and number of incidents and accidents are happen when the person is performing testing, troubleshooting, or voltage measuring. So in your organization, just like the thing which I talk about in article 110.4 related to a normal operating procedure. So you know about the concept of normal operation, normal operating condition, but when you are developing your own electrical safety program, just ignore it and make and don't include don't include this normal operating condition clause in there, and make all the type of the work as a energized task. Similarly, for this one, for energized selective work permit, okay, don't put an exemption. Make mandatory requirement in your electrical safety program that it's a mandatory requirement that you should complete an energized selective work permit for the task which you are performing in your organization. Right? Okay, this I have put here just to make you one thing clear, that permit to work is not equivalent to energized selective work permit. Here they have mentioned permit to work required as applicable at location. Energized selective work permit is different to permit to work. So key points: energized selective work permit exemptions require that safe work practices be followed and that appropriate PP be worn, which includes both shock protection PP and arc flash PP as required. So there is an exemption to permit, but there is no exemption to selecting and wearing the personal protective equipment. So a risk assessment need to be performed. So energized selective work permit exemption require that safe work practices to be followed and that appropriate PP to be worn, which includes both shock and arc flash PP. It's a good practice to use an energized selective work permit even when it is not required. Okay, although an energized selective work permit is not required for condition listed here, you are still permitted to generate one. Okay, to generate one. You may want You may want our work permit to document what is expected of you and how you will be protected when conducting justified energized work when testing or troubleshooting. Okay, an employee conducting voltage measurement without an energized selective work permit may notice a loose conductor in a terminal and consider that it may need to be tightened. Is he allowed to carry out this task? So the answer is no, because the energized selective work permit, which he did not completed an energized electrical work permit for voltage task, but in order to perform some tightening of the loose connection, risk assessment need to be performed, in which we will going to determine whether the energized work is allowed or not, or if that energized work is not allowed, then we have to establish an electrically safe work condition. But if it falls under the exemption category that the task can be performed on the live and energized work can be performed, then an energized electric work permit will be completed for this particular task. Okay. This type of the question you can expect in exam. Which depicted task requires an energized selective work permit? On the left, he's performing voltage measurement. On the right, the low voltage racking in and racking out. So we have seen that voltage testing on the left does not mandatory require energized electric work permit, but the racking and rack out will be requiring those energized electric work permit. So low voltage does not meet the 4 exemptions for completing an energized electric work permit. So this task will be requiring energized electric work permit. Do I need an energized electric work permit? Testing of 400 volts test equipment. So for testing, energized electric work permit is exempted, so it's not required. So however, he may still want to document what is expected of him and how he will protect while conducting that justified energized work. Next one, if Mike fills out a permit for his troubleshooting task, what would he select as a justification for performing the energized work? So this is the tasks mentioned here, and they have mentioned 4 things. Just go through this task and select any one options here. All these options comply with Article 110.4. Okay. So under this condition, what will be the right option? The right option is that it is infeasible to troubleshoot on equipment that is de-energized. So if this type of the option or if this type of the things will be there, then you are allowed to perform those tasks in the live system. Verification of an electrically safe work condition is a type of the diagnostic task. Yes, because we are trying to identify whether the circuit have been correctly isolated or not, or there is some residual charges are there. So it's a type of the diagnostic task. Energized work is permitted when the employer can demonstrate that de-energizing introduces additional hazard, increased risk, or it's infeasible. Is measuring voltage and activity that requires an energized electric work permit? Yes. Sorry, voltage measurement does not require an energized work permit. No, but all other requirements of Article 130 apply. So C is the right answer. Because other things related to selection of the personal protective equipment, the qualified person, the requirement of only a qualified person to perform that particular task, etc. and etc. So those need to be mandatory requirement here. As per NFPA 70, the point where an electrically safe work condition is verified is considered to be an energized work. Yes, because till the point we have not performed the verification, we will going to consider that task as an energized work. The approach boundary no longer exists once an electrically safe work condition is established. Yes, once an electrically safe work condition is established, the approach boundary does not exist. Qualified persons are allowed to improvising procedure while they are performing a justified task. No, they are not allowed to improvise. They only have to follow the written process and the procedure. So what procedures are there? They have to follow those. Okay, moving to risk assessment procedure. The risk assessment procedure follows the same ISO 31000 thing. First, you have to identify the hazard, you have to perform the risk analysis, risk evaluation, and apply the controls, and then have to monitor whether those controls are working for you or not. If no, then again that cycle will goes on and on. So the same framework is being used here in NFPA 70 as well. 130.4 talks about the shock risk assessment. Yeah, this is same from ISO 31000. You can also find this framework in Annexure F as well. So I've taken it from table F.3 hierarchy of risk control in Annexure F. It basically complies with ISO 31000. Okay, 130.4, it's about the shock risk assessment. Risk of electric shock. So during the shock risk assessment, what we are actually doing, we are trying to identify the voltage level to which the person will be exposed, and what will be the distance of those exposed energized electric conductors. So what is basically the safe distance? So we will be coming up with the limited approach boundary and the restricted approach boundary, and during the one of the outcome of the shock risk assessment will be the voltage level. So shock risk assessment identify the shock hazard, estimates the likelihood of injury or damage to health and potential severity, determine if additional protective measures are required. That is related to the personal protective equipment. So severity of the possible injury increases with the voltage level. Yes, as the voltage will going to increase, the severity of the injury will also going to increase as well. The likelihood of direct contact with conductor increases as the distance to the exposed energized electric conductors. What's your opinion on this question? As the distance from the exposed energized electric conductor decreases, as the distance decreases, the chances of getting electrocuted or electric shock increases. Okay, then moving forward, how we will going to estimate the likelihood and severity. So in order to estimate the likelihood of occurrence of injury or damage to health and the potential severity of injury or damage to health, shall take into the consideration all of the following: the design of the electrical equipment and the electrical equipment operating condition and the condition of the maintenance. So when we are taking into the consideration about one, if we have one MCB at location 1, and there is another MCB at location 2. So if we want to know that that which the likelihood of electric shock is more high in MCB1 as compared to MCB2, first we will look into the design of those electrical equipment. Design wise, which one is safe and which is taking into the consideration the human safety factors. And another thing is related to the electrical equipment operating condition and the condition of the maintenance, whether that equipment have been maintained over the period of time and what is his current condition. The poorer the condition, the chances of electric shock are there more higher. And then it talks about some additional protective measurement. So the additional protective measures required: the voltage to which the person will be exposed, the boundary requirement, the limited approach boundary and the restricted approach boundary, and the personal and the protective equipment required for that particular question. Yes, Mr. Johnson.
Sir, for this shock risk assessment, sir, this is independent as per the equipment, yani life cycle perspective. It is independent, this shock risk assessment.
Basically, if you are taking into the consideration the life cycle concept, that the aged the asset and its condition is not good, the chances of electric shock with that particular assets are higher. So here they are taking into the consideration the condition of equipment itself, the electrical equipment operating condition. So if their normal condition is not good, it has deteriorated over the period of time, then the chances of electric shocks are higher in those electrical equipment. And if they are not maintained over the period of time, for example, their earthing have not been verified, so we will not going to consider that electrical equipment to be safe. Okay,
sir. Okay.
so the one of the outcome of the shock protection is the the shock risk assessment is the boundaries, which we discuss about the limited approach boundary and the restricted approach boundary, and how we are performing those risk assessment. We have discussed about the table 130.4 E-A and 130.4 E-B. So once we know about the voltage and we know about the type of the conductor, whether it's an exposed, movable or fixed conductor, we will be using that particular column. So if you are working at voltage level of 132 or 145 kV, so the limited approach boundary for the fixed conductor will be around 10 feet and 0 inches, and the restricted approach boundary will be 3 feet and 10 inches. If that is a movable conductor, then it will be 10 feet and 8 inches, the limited approach boundary, and the restricted approach boundary will remain same. So the outcome of the shock risk assessment will be the shock protection boundary, the limited approach boundary, and the restricted approach boundary for both AC and DC circuits. And we can map like this, that this is basically the equipment, what will be its boundaries: shock, limited approach boundary, and the restricted approach boundary. So this person is currently not in any type of the boundary, because the covers are in place, but he knows that once this cover is removed, he will going to find himself within the shock protection boundary as well as within the arc flash boundary. So that's why this person is wearing the complete personal protective equipment. The label which indicate about the shock protection hazard and the arc and against the arc flash hazard, and what is recommends the PPs he is wearing, and he is trying to open the panel. So this type of the question you will going to find in exam. They will going to ask on the scenario which we discussed before, that there was a CNC machine which had failed. So they will going to ask the same scenario, and then they will going to put this question: what is the limited approach boundary for that particular task? So if we remember the voltage level So the voltage level was 480 volts, and they have given us a 1200 ampere fuse value as well. So we don't have to take into the consideration the ampere value. We will look into the voltage level, and based on the voltage level, we will go into the table, and the outcome of the table is that 3 feet and 6 inches is the right answer for the limited approach boundary. Similarly, what is the restricted approach boundary? So 1 feet is the right answer. So from table 130.4 EA, the voltage level falls under this category, 151 to 750 volts. So this is basically the limited approach boundary and the restricted approach boundary. 3 feet and 6 inches and 1 feet is the right answer. Any questions up till now on this one? Shock
No,
risk
sir.
assessment.
No,
Moving
sir.
to 130.5 arc flash risk assessment. So first thing which we were going to ask whether the arc flash hazard exists or not. So arc flash hazard does not exist if the incident energy is less than 1.2 cals per centimeter square, or if the equipment condition is normal, right? Yes, Janjay, please.
Sir, this is totally, I guess, irrelevant, but I want to ask this
Yeah, sure.
uh, arc blast energy, sir, how much, you know?
Basically, arc blast is not in terms of energy, is in terms of pressure. It's pound per foot square. Arc flash is energy. Arc blast is not energy. Arc blast, if you look in the first lecture, we discussed about the arc blast. It's basically the pressure wave component. Okay, so that's why the PPs which are mentioned here in 70E does not provide you protection against the arc blast. So what is an outcome of an arc blast? That due to arc blast, one person can be thrown from here to another maybe 10 meter or 10 feet distance, or enough pressure waves will be felt on its chest that can cause some break of the bones, or due to loud sound, the deafness can occur. So 70E does provide that you should be wearing hearing protection. So that hearing protection is one of the thing which will going to provide protection against arc blast, uh, loud sound. But what about other things? The penetration of the molten metals within the body, that is also part of the arc blast. So arc blast energy is not there, arc flash energy is there, and arc blast is associated with the pressure.
Okay, sir.
Okay, so an arc flash risk assessment shall be performed to identify the arc flash hazard, whether the arc flash hazard exists, to estimate the likelihood of occurrence of injury or damage to health, how much severe it is, and to determine if additional protective measures are required or not using the use of any personal protective equipment, PPs. So estimate the likelihood and severity. So in order to estimate the likelihood and severity, we will look into the design of the electrical equipment, including its overcurrent protective device and its operating time, whether there is an overcurrent protective device setting is there or not, and what is its operating time and how much time it is taking for operations. So electrical equipment operating condition and the condition of maintenance, these are the two things as well, which need to be taken into the consideration. So when assessing the risk of an arc flash hazard, key components to consider are as follows: design of electrical equipment, overcurrent protected device and its operating time, electrical equipment operating conditions, and maintenance equipment manufacture. What's your opinion? It's a multiple choice question. Yeah, the right answer is design of electrical equipment, overcurrent protected device and its operating time, the electrical equipment operating condition and condition of maintain. ABC are the right answer. Equipment manufacturer is not the right answer, because normally we are not taking into the consideration this when we are performing an R flash hazard. But if particular type of the manufacturer or the particular type of the equipment in an organization has some problem and it is causing frequent failures or flash, then this could be taken into the consideration for that particular organization. Or okay, but that that might not be the thing for the other organization. So it is very specific for one organization to another organization. On the other hand, ABC are okay. That is covered in Article 130.5. So first thing is that if an R flash hazard exists, an R flash risk assessment need to be performed. So 130.5C have given you number of tasks which you are performing in an organization, and in the second column it takes into the consideration the equipment condition, and the third column talks about the likelihood of occurrence. So in 130.5C, if you look into the standard, there are more than 50 to 60 tasks are given. (130.5C). So here is a list of the tasks which you might be performing within your organization. The second column talks about the condition of equipment, whether the equipment condition is normal, abnormal, or it could be any, and the likelihood of occurrence. Likelihood of occurrence means the likelihood of occurrence of an arc flash. So reading a panel meter while operating a meter switch, equipment condition is any, the likelihood of occurrence is no. We are just reading a panel meter. Working on control circuit with exposed energized electric conductor and circuit parts, nominal voltage is this, equipment condition is any, the likelihood of occurrence is no. So if the likelihood of occurrence is no, we won't be carrying out the R flash risk assessment further as per 70E guideline. But if your organization suggests that for this particular case the likelihood of occurrence is yes, then you will be conducting the R flash risk assessment based on the incident energy analysis method or the PP category method. So first thing you have to look, what is the task in hand. You will going to compare that particular task with table 130.5C. If that task is there, the equipment condition, then you will going to check the equipment condition, and then you will check, and then you will going to decide whether the likelihood of occurrence is yes or no. So if the likelihood of occurrence is no, then you will stop. But if the likelihood of occurrence is yes, then you will going to further carry out your risk assessment. Right? Any question on this table clarification?
No, sir.
So for example, in exam, you will going to find these type of the question. Opening hinge door or cover to expose bare energized electric conductor or circuit part, equipment condition is any, is an arc flash risk assessment, is an arc flash incident likely? So let me take you to the standard. Opening and hinge door, it says. We will going to find here what it says here. Opening hinge door covers or removal of bolted cover, etc. Equipment condition is any, the likelihood of occurrence is yes. Okay, so the here answer is an arc flash risk assessment is likely yes. The answer is yes based on table 130.5C. Similarly, perform infrared thermography or non-other contact inspection outside the restricted approach boundary. Is this activity does not include opening of the doors? Is an arc flash risk assessment likely? The answer is no as per the table, because you are not opening, you are not coming in direct contact, so the likelihood of occurrence of arc flash is no. Okay, then we have discussed about what are the different type of the methods you can use to calculate the arc flash boundary. So first method is the incident energy analysis method. So the incident energy analysis method, in this particular method, what we are doing, we are basically analyzing the complete network. We are modeling that network, and then we are calculating what's the available incident energy is there. So one of the following methods shall be used for the selection of R flash PP and determination of the boundary. Either the incident energy analysis method, which is covered in 130.5G, or the R flash PP category method, which is covered in 130.7 C15. So both this method cannot be applied on the same piece of equipment, but both this method can be applied in your industry. So maybe you are performing incident energy analysis method for your high voltage site, but you are using an arc flash PP category method for your LV network. It's allowed. It's also allowed that you are using incident energy analysis method and the arc flash PP category method for your HV system as well as for your LV system mixed. So some HV system have been evaluated based on incident energy analysis, other have been based on PP category method. But what is not allowed is that a transformer number 1 cannot be assessed or should not be assessed based on both the method, or both the method information is available on the same piece of equipment. So either but not both the methods shall be permitted to be used on the same piece of on the equipment. The results of an incident energy analysis to specify an R flash PP category is which is specified in 130.7 C15C shall not be used when you are using another method. Okay, so there is a clear-cut method given that if you are using 130.5G, you will be using PPs based on 130.5 G table. If you are using a PP category method, then you will be using selecting PPs based on 130.7 C15C. Both the methods are approximately similar. They are taking the same input, like available fault current, the fault clearance time, the system voltage, working distance, and the arcing current, etc. But there are some changes. If you are using an R flash PP category method, we have to follow that table method. And if our exact scenario is there in our table, we will be using either 130.7 C15B or 130.C15A. 15B is for the DC system, 15A is for our AC system. So we will be using either of these, and then we will be moving to 130.7 C15C for selection of our PPs. If we are using an incident energy analysis method, we will be using table 130.5G, and then we will be selecting PPs based on our table 130.5G. So we cannot say that if we have started an incident energy analysis method for the selection of our PPs, and we are selecting PPs based on 130.7 C15C, or if we are using a PP category method and we are selecting PPs based on 130.5G, this is not allowed. This crossing is not allowed. So if you are using PP category method, you will select the PPs based on table 130.7 C15C. If you are using an incident energy analysis method, you will be selecting the PPs based on table 130.5G. Okay. So this is a table 130.715A. So all the equipment requirements and the parameters need to be exactly matching. Once they have matched, you will be using an arc flash PP category 1, and you will be developing an arc flash boundary of 19 inches. If the information is not available here, then you cannot use this table. Okay, then you have to use incident energy analysis method. So once the equipment is there, the parameters are matching, you have identified the PP category, you have identified the boundaries, you will move to 130.7 C15C for selection of your personal protective equipment. For example, if the result was a PP category 1, so you will use 130.7 C15C PP category 1. What are the PPs mentioned here? You will be selecting those for the execution of the task. So in this table, you will going to find AN, which stands for as needed. Why as needed? Because you might not be needing an R-rated rainwear jacket, parka, or hard hat liner if you are working in other condition, or maybe if you are working in rainy season, then you will be using a rain wear. If you are working in cold, you might be needing jacket, but these might not be needed every time you are performing job. So other things are mandatory. Then there is an SR written. SR mean selection required. So either you will be using a safety goggles or you will be using safety glasses, or you will be using a leather footwear as needed, or dielectric footwear. So once you know from 130.7 C15A or 15B, then you will be jumping into 130.7 C15C for your selection of your personal protective equipment. So this is the right manner. You are not jumping into 130.5 G to select your PPs. On the other hand, if you are using okay, these are small Q&A. On the other hand, if you are using an incident energy analysis method, okay, so you will start with an extra D, which is not mandatory requirement. So an extra D have different type of the methods given related to performance of the incident energy calculation method. So most preferred method is IEEE 1584 2018 edition. So you have drawn the complete circuit, and you know about the available incident energy at particular locations. So based on that one, you will be using 130.5 G table for the selection of your personal protective equipment. So we will focus on IEEE 1584 method. So these are the minimum requirements to draw any model, like single line diagram, obtaining the impedance and rating, review the protection settings, perform fault studies, perform the arc flash calculations according to IEEE 1584. Okay, so we have performed the modeling. Once the model is performed, the outcome is 18.7 cals per centimeter square at a working distance. So we might be choosing the personal protective equipment or PP of 24 cals per centimeter square, or 36 cals per centimeter square PP is used. So we will be moving to table 130.5 G for selection of our personal protective equipment. So this table 130.5 G will going to talk about what PPs you have to select. So the outcome was, for example, 12 cals per centimeter square. So this one is related to 1.2 to 12 cals per centimeter square. So all the PPs mentioned here you will be using. If it is greater than 12 cals per centimeter square, you will be using this particular set of personal protective equipment. So what is the basic difference between upper and below? In this one, it gives you a selection requirement between an arc rated face shield, arc rated black hour, or arc flash suit hood. Here, you cannot wear an arc rated face shield with an arc rated black hour. You have to wear an arc flash suit hood, which is a mandatory requirement. Okay. So these type of the things are mandatory requirements here. So also we have seen that lack of the maintenance can increase our overcurrent protective device clearance time. The larger and smaller amount of available short circuit current can also increase the incident energy. So these are the factors which we need to take into the consideration. Yeah, this graph we have discussed before. If the distance between a person and the potential arc source is different from the dimension used by the analysis method, the actual thermal energy might be greater or less than that determined in the analysis. This is pretty much true. So if we want to summarize about the arc flash risk assessment, everything will going to start with table 130.5C. You will look into the task. Okay, based on the task, whether the task and the equipment condition, whether the likelihood of occurrence is no or yes. If the likelihood of occurrence is no, we won't be performing R-flash risk assessment further. But if it is yes, then we will be performing an R-flash risk assessment either based on the incident energy analysis method or the PP category method. So if the answer is yes, we will be viewing this table. Based on the outcome of this table, we will be selecting our PPs directly, or we will be using an extra D or IEEE 1584 method of the incident energy analysis method, and then we will be selecting PPs. This type of the question you can also find, you will be finding in exam. For example, they have mentioned here an incident energy analysis was performed and the incident energy was around 14 cals per centimeter square. Okay. Use table 130.5 G. So they are very, they have mentioned table, but normally this is not the case. But let's suppose they are directing you to select the PPs based on this table. So select a PP system by dragging and dropping the choices of the PP in the PPs bag. So you will going to refer to 130.5 G. You will going to find, okay, 25 cals per centimeter square coverall is required. R-rated suit hood is required. R-rated gloves is required. Rubber insulating gloves. What I will going to do with the rubber insulating gloves when I have an R-rated gloves with me? Rubber insulating gloves is for shock protection, so this is not required. Ear canals is required if there is some blast is there. Safety glasses is required, hard hat is required. So all the PPs are required except for rubber insulating gloves. So once we know, then we can select our PPs based on the information given. More on the PPs we will going to cover in our module number 5. Okay. So up till now, I just wanted to make you people realize that where you can find the details about the personal protective equipment. Any questions up till now?
No, sir.
Okay. R-flash hazard equipment labels. So these are the two outcome of the R-flash risk assessment and shock risk assessment. So if we are using an incident energy analysis method, we will be using this type of the label, because here it says about the available incident energy, working distance, and the minimum arc rating of the clothing. If we are using a PP category method, we will be using this type of the label because it talks about the PP category 1, 2, 3, 4. We cannot use this label for incident energy analysis method and this label when we are using a PP category method. That will be wrong. So if we are using this one, we know about the incident energy available, the working distance, and the minimum arc rating of the clothing. And if we are using this one, we know about the PP category, whether it's 1, 2, 3, or 4. Right. So these are the journal points. One thing is we have to remember that if we are performing an incident energy analysis method, there is a requirement that the incident energy analysis need to be updated, revised every 5 years. If no major changes have happened in the system, if the major changes have happened in the system, some transformer have been added, some generator have been added or removed. So those changes will have an impact on the incident energy of the system. So that's why it is recommended that the R-flash study need to be performed quickly. Otherwise, it's a requirement that the incident energy analysis need to be performed every 5 years, once in 5 years. So this is not the requirement that, for example, if the incident energy is 6.4, you should always apply a factor of 1.25 or 125% to increase the incident energy from 6.5, 6.4 cals per centimeter square to 8 cals per centimeter square. It's not a mandatory requirement, but if you are doing it, it's one of the good practice, because we know that due to ABT or EBT, there is still a 50% probability that the personal protective equipment might not going to perform well if they are exposed to the equivalent amount of the incident energy. They will going to ask an exam whether this type of the the label conform to 70 requirements? So the answer is no, because it is not talking about the shock risk assessment, R-flash risk assessment, either based on the incident energy analysis or the PP category method. It might going to fulfill the requirement of NFPA 70 or the NAC, but it is not fulfilling the requirement of NFPA 70E. Some do's and don'ts of this ARC labeling. Once we have done this labeling, what are the issues? People think that we have performed a risk assessment, we have put the label that now it gives us a right to perform the task on the live system. So this is not like this. The labels are there to warn people, not to give them the right to perform the task on the live. Only this label does not complies with the 70 or OSHA requirement. We have other requirements as per 70 which need to fulfill, like development of the electrical safety program, training requirement of qualified and unqualified persons, and other requirements which we talk about the safe work practices. Do for the label for the worst case scenario. What does this mean? This means that if there are different type of the team might be working on the equipment, some might be working at a working distance of 36 inches, other will be working at 24 inches, and other might be working at 18 inches. So as the distance is different, so the incident energy will be different. So we won't be putting 3 labels on that particular equipment. We will be only putting 1 label for the worst case scenario, which is about how it will look like when we are working at only minimum distance at 18 inches, right? So don't label multiple label, only label for once, which is the worst case scenario. Similarly, if there are, yeah, what's your question? Yeah, so if there are multiple, for example, scenarios in which in some scenario the fault current is low, in some scenario the fault current is high, so we will going to label our equipment for the worst case scenario. Okay, the worst case scenario will be that scenario in which the maximum available fault current will be there and the maximum arc flash energy will be there. Okay, so summary, if we want to summarize, determine if energized electric work permit is justified. We will going to we have talked about complete and energized electric work permit and performance of the shock and arc flash risk assessment. So by this we have completed our module number 4, and majority part of the article 130. We will start module number 5 and we're going to complete in our next coming session. So once we have completed the module number 5, we are done with 90% of the course. Okay, and then we might require one more class for the completion of another topics. So what's your availability these days for program? Because I've seen that other people are not coming, and they are might relying on the recorded lectures. So if you are available, we can conduct classes and can close these sessions.
I am definitely, sir, available
You are. So what is the best time for you? It's like if we have some session, there is a difference. Sorry.
Anytime, I am flexible with any time.
Okay, I will go to text you, and then we will discuss about your availability and can conduct the session accordingly. Okay, so maybe tomorrow, like tomorrow, if you are available for 1 hour or 2 hour, like there is a 3 hours difference now. What time it is right now in Saudi Arabia? It's 8:30, 8:40.
Yes.
8:40. So if you are available 11 a.m. tomorrow, 11 or 12 p.m. tomorrow, we can have a session, 1 hour, 2 hour session. Okay, great. So I will let you know once I am up tomorrow morning. Just text me as well, so we can schedule the session.
Okay.
Okay, thanks a lot. Thank you. See you, inshallah. Assalamu alaikum.
Walaikum salam.